All right, everybody, let's get into this. So, first video of this semester, we're talking about Intro to Arithmetic and Geometric Sequences. Let's start with some learning objectives. First objective, we are going to identify whether sequences are arithmetic or geometric. And then after that, our second objective, we're going to identify the common difference of arithmetic sequences and then the common ratio of geometric sequences. So first off, let's define what that even means. So to begin with, a sequence sounds a little complicated. It's really not. It's just a list of numbers, a series of numbers in a specific order. It's a list of numbers that follow a pattern. For arithmetic sequences, it's a numerical pattern that increases or decreases at a constant rate called d, which is known as the common difference. A geometric sequence, very similar in that it follows a pattern, but instead of increasing or decreasing at a constant rate, it increases or decreases by a multiplier. It is found by multiplying the previous term by a constant r, which stands for constant ratio. So basically, to sum it up, arithmetic sequences, we're either adding or subtracting to get the next number, when geometric sequences, we're either multiplying or dividing, which you're going to see as multiplying by a fraction, to get the next number. With that in mind, let's get into our examples. Here's the first one. It says, determine whether the sequence is arithmetic, geometric, or neither. So if it's not arithmetic, if it's not geometric, we don't really care what it is. For the sake of this lesson, we're just going to call it neither. So looking at this list of numbers, this sequence, we have 0, then 8, then 16, then 24, then 32. The first thing to check for is whether it's arithmetic or not, because that's just easier to check. Am I adding or subtracting the same number, number after number? If I go through this list of numbers, I see from 0 to 8, by subtracting, it gets me 8. 16 to 8, subtracting, another 8. 24 to 16, 32 to 24, they're all 8s. So this list of numbers, this sequence, follows a pattern, follows a common difference of 8, which makes it arithmetic. Adding the same, subtracting the same, arithmetic. Second example, determine whether this sequence is arithmetic, geometric, or neither. So this time we have 64, 48, 36, 27. Looking at this list of numbers, going through the same thing we did before. If I do 48 minus 64, then 36 minus 48, then 27 minus 36, I end up with different numbers. This does not have a common difference. So this will not be an arithmetic sequence. Because of that, we need to check to see if it's geometric. If it's not geometric, then it's neither. So to check if it's geometric, let's divide these numbers. And just like how we did in the previous example, let's do it by kind of going backwards. Let's subtract them. So 48 minus 60, or divided by 64, reduces down to 3/4. 36 divided by 48 reduces to 3/4. And then 27 divided by 36 also reduces to 3/4. So all of these numbers have the common ratio 3/4, which makes this a geometric sequence. This is a hard one to tell when you're multiplying or dividing. When you're multiplying by a fraction to get from one number to the next, but this is still geometric. I want to really emphasize this one here because this is going to be like the trickiest ones of geometric to see. But you can always find it by dividing the two numbers, reducing it, and seeing if that fraction is the same throughout your entire list. So there's the first two examples, determining whether it's arithmetic, geometric, or neither. Now let's find our common differences, or let's find our common ratios. In this example, it says find the common difference. So since it's asking for a common difference, we know it's arithmetic. We know that we're either adding or subtracting every single time. If I go through this list here, I have 40, 30, 20, and 10. Now this one's probably a little easier to see since we're just counting by tens, but what am I changing by every single time? How much lower am I going every single time? And since I'm dropping 10 every single time, that's my common difference of negative 10. So I know it's arithmetic. It changes the same way every time. And since it's changing by subtracting, it makes it arithmetic. And I know what that subtraction is. It's negative 10, which is my common difference. One more to go. Looking at another sequence. This time, let's find the common ratio. Common ratio gives us a hint that it's geometric, meaning we're either multiplying or dividing to get to the next number. So this sequence, I have 1, negative 8, 64, negative 512. This one's a little more obvious to tell it's not arithmetic because clearly from 1 to negative 8 and then from negative 8 to 64, that's not adding or subtracting the same amount of numbers. So to change your sequence, your list, by that large amount, you have to be multiplying. So let's find out exactly how much we're multiplying by dividing each term from the next. So if I'm looking at this one, I have 1 to negative 8, which I can find by dividing the second term by the first term. So negative 8 divided by 1 gives me negative 8. I can find the next one by going 64 divided by negative 8. Also gives me negative 8. And then the last one, you could probably guess, but that negative 512 divided by 64 gets me negative 8. Notice the negative 8s. That's my common ratio. That's the end to this problem. So big picture, guys, big thing we should have gotten from the day, going back to our learning objectives. We should be able to tell whether a sequence, whether a list of numbers is arithmetic or geometric. It's arithmetic if you're adding or subtracting the same number every time. It's geometric if you're multiplying by a whole number or a fraction every single time. You guys try some of these problems. Determine whether the sequence is arithmetic, geometric, or neither. You have 1, 7, 49, 343. Hopefully you noticed it's changing by a large amount, so it's not going to be arithmetic. Looking at this thing from 1 to 7, you times by 7. From 7 to 49, you times by 7 again. So this is a geometric sequence. Determine whether this one is arithmetic, geometric, or neither. You have 1, 2, 4, 14, 54. This one's a little trickier because it starts off geometric. 1 times 2 makes 2, 2 times 2 makes 4, but it doesn't continue that pattern. If anything, it should have been 8 next, then 16 after that, but it's not. It changes to 14, then it changes to 54. So geometric's off. 1 plus 1 makes 2, 2 plus 1 makes 3. Arithmetic is off as well. This one turned out to be neither. It doesn't truly follow a pattern. That's all we've got for today, guys. Intro to sequences, looking at a list of numbers and determining whether it's arithmetic or geometric, and then finding the common difference for arithmetic sequences and the common ratio for geometric sequences. Thanks. Let me know if you have any questions. Talk to you guys later.